Today we will be discussing, or we are going to start with the Hamiltonian formalism. And already we discussed Lagrangian formalism. Here, why we are discussing Hamiltonian formalism by now itself is the because once you have L and H, you understand what is L, what is H. Once you have a given problem, you are able to derive both L and H. Okay, so it's like a two-way. Once you have L, you are able to get H. Once you have H, you are able to get L. Right. So this the which can be done with the help of a Legendre transformation, as I mentioned here. Right. So we will solve a problem. For the time being, we will understand what is meant by H's and what is the advantage of having H, and what are the equations of motions. What is the advantage of having Hamiltonian, right? So H is a function of generalized coordinate, momentum, and time. It's not a momentum, it's a generalized momentum. As I told you earlier, we have a generalized coordinate, right, and generalized momentum, right? And once we have L, we are able to find P with the help of this equation, that is pi equal to dou L by dou Q dot. This is the most important equation in order to find P, right? So this is the key thing. Once you have a Lagrangian, you are able to write pi is equal to dou L by, just you have to differentiate with qi dot, you are able to get pi, and then you are able to transform that in terms of uh, qi dots, right? So once you have this, you are able to write the Hamiltonian, which is a function of qp and t, right? And you have to transform this q dot into into pi's, that is the generalized momentums, with the help of this equation, right? So for the time being, bear with me, I will be discussing this, I'll be doing this while solving a simple harmonic oscillator problem. Then we will get into some complex problems, right? So then here we have a Hamilton's equations, that is qi dot equal to dou h by dou p and pi dot equal to dou h by dou q, right? So these two are Hamilton's equations of motion, and you can observe this is these are the first order differential equations. Okay, compared to Lagrange's equation, the solutions for these equations can be attained with the help of a single integration. Right, that's the most advantage. Instead of having second order differential equations, you are able to have the first order differential equation. Right, that is the most advantageous thing you have in this Hamiltonian formulas. Right, for the time being, we will wind it up. Then we will discuss a problem with the by transforming this, and we will get into problems, and we can simultaneously derive Lagrangian and Hamiltonian, or we can transform from one formalism to another formalism in upcoming lectures. Stay with me.